this section, I'm going to talk about area between two curves. So what we have here is that we have two functions. One is f of x and the other is g of x. So here we can see that we want to find the area that's bounded by f of x and g of x. Now in this diagram we have that the two graphs actually do not meet technically, from A to B at least. So that's one thing that we need to be careful with. So in finding the area, well, it makes sense that we could find the area of f of x and then we could find the area of g of x, but we want to get the in-between part. So what that means is that we have to integrate from A to B, and we have to take the fx and we have to subtract the plot function. So we have g of x and then we have dx. Now, in essence, this is what we call top minus the bottom. So, in this sense, all that we need to do is just know which function is higher between a and b, which means that we could always just probably choose an intermediate value. So, for example, if you had, let's say y equals x squared, and you had y equals x plus 2, well, the thing that we need to verify is that we can find their points of intersection. So, for instance, I would first go ahead and find that x squared is equal to x plus 2, but then I would have x squared minus x minus 2 is equal to 0. This factors as x minus 2 and as x plus 1 equals to 0. So this means that the points of intersection are at -1 and at 2. So what that means is that I would have to basically kind of just see that the region that's bounded by these two curves is wherever they intersect. Sometimes you do have that you want to integrate from A to B, like where A is a vertical line and B is a vertical line. Okay, so we'll just draw like that. Now it says that x plus 2, it would look something like this. So in this case, we have that this function goes like that. We have that the points of intersection are right there and right there. Now, if you want to write those in, then you know that that would be -1, comma, 1, and then this would be 2, comma, 4. Okay, now that would mean that the region that's bounded by the curves is right here. Now, I mentioned earlier that we can just go ahead and say, well, how do I know which one is the top, which one is the bottom if I don't have the graph? Well, you could always plug in, like let's say 0. So y equals 0 squared, y equals 0 plus 2. Well, it's kind of clear that the one that's greater is the x plus 2. So that means that the x plus 2 is the one that is on the top. So we have that we would do x plus 2 minus x squared. So that's exactly what we would do. We would say, okay, the area is equal to -1 to 2, and then we have x plus 2 minus x squared. Now, what this would give us basically is just the antiderivative, which is x squared divided by 2 from -1 to 2 plus 2x from -1 to 2, and then we have that would be minus 1/3 x cubed from -1 to 2. So all that we need to do here is just go ahead and subtract the 2. So we have that that would be 1/2 multiplied by 4 minus 1, and then we have plus 2 multiplied by 3. So we have 2 plus 1, which is 3, and then we have negative 1/3, and that's going to be 8 minus, well, actually it's going to be plus 1. So we go ahead and we simplify this as best as possible. So we have 3/2, we have plus 3, 6, okay, so that's 6, and then we have minus 1/3 times 9. Okay, so this will be 3/2 plus 6 minus 3. So that's equal to 3/2 plus 3, which is 6. Okay, so that's going to be, yeah, 6 9/2. Okay, so we have that that's going to be 9/2 units squared. Okay, so in other case, what you can probably do is try another example. So like what you can do is maybe try okay, so I'll go ahead and put that you should try to find the area that's bounded by 4 minus x squared and y equals to this one will be x plus 2. Okay. And then see what you got. It may be not so much different from the one before, but just try and see. Now, let's go ahead and look at another equation. So let's say that we want to find the area. And we're just going to say that it's bounded by y equals 2x and y equals to 8x squared, or 8x minus x squared. Now, these actually are pretty easy to graph in this case, because I know that 2x is just a line through the origin, and I know that 8x minus x squared is just a parabola just pointed downward. So all that I need to do is just draw our parabola. And we'll just draw it like that. And then we need to draw 2x. Okay, so 2x, okay, so let's see. We'll draw 2x like that. And we'll just say that it's not to scale. Okay, so that means that the region that lies beneath the two curves looks something like this. Okay, now the thing that we're missing basically is the points of intersection. So we have to take 8x minus x squared, and we're going to subtract, or not subtract, but say 2x. So let's say that we go ahead and we move things around, and we have 8x squared, or sorry, x squared minus 8x. Let's see. Right, so that'll be plus 2x then, equals to 0. So this gives us that we have x squared minus 6x, and that equals to 0. Okay, so from here we just take x and then that's multiplied by x minus 6 and that's equal to 0. So the points of intersection are 0 and 6. So note that basically the parabola is the one that's on top. So um, notice that basically when we did our subtraction that I moved everything around so that this becomes positive. So in that case, what you see right here is actually like if this is g of x and this is f, what I wrote down over here is actually g minus f, so it's the other way around if you think about it. So all that that means is that, right here where you see g minus f, you can basically just flip it. So in that case, that'll just be a little bit easier when you do the subtraction, or just the simplification, if anything. So we have that the area is equal to the integral from 0 to 6. And then we said that basically we just have the same thing, but just need to make it negative. So we have negative x squared plus 6x, and that's dx. So this is equal to negative 1/3 x cubed plus 3x squared. And all of this is from 0 to 6. Now, interestingly enough, you have that the 0 doesn't matter because you know that it's going to be 0. So this equals to negative 1/3 times 6 cubed plus 3 times 3 times 6 squared. So, okay, so what we have here is that you end up with negative 216 divided by 3, and this is going to be equal or plus 36, so that's 108. Yeah, so we have that this is going to be 108. Now what you do have here is that this is 72, so that means that this is going to be equal to 108 minus 72, which is equal to 36. Now be careful with that because it's 36 units squared. Now, interestingly enough, I could probably go ahead and use Desmos if I wanted to, and see like over here how I plugged in 2x, I plugged in 8x minus x squared, and you can see that the vertex was at 4, so I kind of got lucky there that what if it was 4? Then then that would be too far, the line that I drew. Okay, so anyways, I point and click and I see that it passes through 0, 0, and then point and click and it passes through 6, 12. So for those that are having trouble with, finding the points of intersection, you can actually always use Desmos and it'll give you the points of intersection. And then, you can see the region that's bounded by the two curves. Now, it is possible that you might be given like more, like, like it'll tell you to find the area bounded by the curves and then also the lines -5 and then maybe like 10. Well, that's going to be a little different because then you're going to have to include this region and this region over here. So that means that the top minus bottom will actually change in that case. Okay, now let's go ahead and look at another example of where we try to find the area bounded by two curves. Now, I'm going to say find the area bounded by, okay, so in this case, this one's going to be a bit similar. So we have y equals x squared and y equals to 6x minus x squared. Now, we'll go ahead and just find the points of intersection by saying um, x squared is equal to 6x minus x squared. Now notice that when we go ahead and we move this over, you get that that's 2x squared minus 6x equals to 0, and then you get 2x times x minus 3 is equal to 0. So what this means is that the points of intersection are x equals to 0 and x equals to 3. Now, I mentioned earlier that if you have trouble figuring out which one is which, you can always just plug in an intermediate value. So like for example, you have that let's say that this is f of x, and let's say that this is g of x. So if you have f of 1, you get 1 squared, which is 1. If you have g of 1, you have 6 times 1 minus 1 squared, which is actually just 5. So that means that the parabola g is on top. So notice that back over here, this is f and this is g, but the simplification part of it, this is f minus g, but we just said that g was on top. So what that means is that basically you would just switch these around also. So that would be the integral from 0 to 3 of 6x minus 2x squared. So don't get rid of that 2. Okay, so this is dx, and then we have that this will be 3x squared from 0 to 3 minus x cubed from 0 to 3. Now when you plug in your answer, you're going to get that this is going to be 3 times 3 squared minus 3 actually there should be a 2/3 there, yeah. Yeah, because if you add a power back, that should be 2/3. So that should be 2/3 multiplied by 3 cubed. Okay. So notice that basically this is just 3 squared, which is 9, that means that it's 18. So this gives you 27 minus 18, which is equal to 9 units squared. Okay, now if we go ahead and we look at the region, I normally would draw the region first, but I wanted to do it without it. Like let's say like we didn't have it. So if we go ahead and we draw it using whatever techniques that you prefer, I know that the parabola looks something like this, the y equals x squared. But then the 6x, basically it's kind of like the same thing. You have that it's a parabola that passes through the origin, and then it goes like that. So that means that the region bounded by the set of curves looks something like this. So, and again, if we had that we were going to integrate from two lines like x equals a and b, then we would also include those. Okay, so if we go back to desmos.com, we can actually change this to x squared, and then change that to 6x minus x squared. So if we click here, that's 0 to 3. Now that means that my graph is off. Yeah, my sketch is off because it's supposed to pass through the vertex. Okay, so that means that, yeah, this is definitely not to scale. But we still found the points of intersection. So, I mean, look, I guess, yeah, we can go ahead and delete this then. Maybe just redraw it. Okay, so we have that. We can just redraw it then. And we just need to make sure that it passes through the vertex. So if we draw our parabola like so, and then we just need to draw our parabola passing through the origin. Okay, so this is a more accurate sketch, but not to scale, most definitely. Okay, so we have that that's going to be the 0, and that's going to be 3. Okay, now what you can do is basically just um, try y equals the square root of x and y equals to x and see what you get when you set those two curves equal to each other. I'll give you a hint that basically that they pass through the points 0 and 1, but you want to find like which one is higher in this case. Um, Now, the thing of which that I'm going to leave you with is that, okay, so let's say that, for instance, that the curves f and g, they did happen to like intersect. So, um, okay, so let's say that, for instance, that they did happen to intersect. And let's just put something like this. Okay, so this is f. So here, let's say that you have your function g. So let's say that you have g, and let's say that it looks like that. Now, here, notice that from here to here, you have that there could be a region that's included. Most of the time, like they'll tell you that it's because you have that there's a line that bounds them, and that line could be like x equals to, um, well, we'll have to use like maybe like a, and then let's say that you have another one right here, and then you call this x equals to b. So what this is doing is it's basically creating multiple uh, regions of the curve. Let's actually use a different color for notating f and g. So here is f, and here is g. So right here, you would have to basically just make note of which functions are going to be which in terms of like top minus bottom. So um, this is a nice little problem because it's telling you that you just have to figure out like this is going to be maybe C and maybe this is going to be D. So that means that you would have like multiple integrals. So that means that basically when it comes to the top minus bottom, it's just going to switch, you know. You have that, it's basically just going to switch off from like top minus bottom, and then you have that it's going to be bottom minus top. So just keep in mind that when you're doing those integrals in their different pieces.